So today we're talking about arcs, just introducing the idea, not getting too complicated with it. But first we need to define what a central angle is. That kind of sets the stage for how we're going to measure arcs. So a central angle, very logically, is an angle whose vertex is at the center of a circle. So we talk about the measure of this angle being a central angle. A few things to note about central angles. They may seem obvious, but for some reason they don't readily come to mind when we encounter a new problem. So total, if we add up all the central angles around this point, they should all total, if they're all adjacent, not overlapping or anything, they'll all total 360 degrees, as that's a full rotation, right? A little more common, and one that people forget a lot, is if I have something like, if I draw a line across here, then each side is 180 degrees, right? So a diameter, any diameter in any direction passing through the center, cuts the circle into two halves that are both 180 degrees. And again, that's just a really common thing that comes up as we're playing around with circles, and it's one that people forget because it's like a number that's not written in the picture, but that you know just upon seeing that there's a diameter. So just an example is right here, find all of the central angle measures. So looking at this, I can see there is a diameter here that gives us 180 degrees on both sides. There's a diameter here that gives us 180 degrees on both sides. A diameter here that gives us 180 degrees on both sides. And those are things that for some reason a lot of people don't see right away. So if we're going to write these out, let's look. Well, this one right here would be 70 degrees because we'd say, well, because of this diameter here, we would say, all right, this is just 180 degrees on the bottom side minus the 110 that we already have. And then on this top side, it's just the full 180 degrees here. And those together total 180 plus the 180 on bottom. That's a total of 360. Okay, down this other one, well, let's look. Okay, so this one right here, AFB, would be 110 degrees because this one would just be the 180 minus 70 because of this diameter going in this direction. Okay, and then, oh, this one over here, AFE, is 70 degrees, and that's just because it's a vertical angle with the 70 below. Okay, well, that only leaves us with one. So to find that one, we could go 360 degrees and subtract everything that we know, or easier is think about it as this is a diameter, and I'm just going to take 180, and I'll subtract my 70 and subtract my 45, and I end up getting 65 degrees. And so that's an easy way to just kind of figure out every single central angle to start a problem. And then afterwards, it might ask you what's the measure of this arc or things like that. And once you have all those angles established, it's much easier to just pick and choose or add them together and whatnot. And so this diagram actually comes from number 3 to 10 on the homework assignment for this. Okay. So now that we know what a central angle is, so an arc is defined as just a portion of the circle's line. So for example, if I just kind of blot out a portion, what's left over is an arc. Okay? Actually, an arc could be the full 360 degree arc too. But in general, we talk about, okay, so there's a different portion of a circle's line. That's a smaller arc. There's a smaller arc, smaller arc, smaller. So it's any portion of that circle's line. Now notice I'm not talking about the points inside the circle, like the area of a circle. We're just talking about the actual exterior line. I'll undo a little bit and leave it as a little longer there. All right. Now we measure, and there's two things. There's an arc measure and an arc length. We'll get to the arc length in a separate section. But the measure of an arc is simply what portion of a circle it takes up. So we define it as the measure of its central angle. Okay, so if the central angle is 40 degrees, we say the measure of the arc is 40 degrees. Okay, now I'll come back and be a little more clear on that, but just to be clear here, that would mean arc ED has a measure of 45 degrees. Arc BC has a measure of 70 degrees. Arc DC has a measure of 65 degrees, and it's because that's the central angle opening up to DC. And what that really is saying is I have 65 degrees out of 360 degrees. It's kind of like a pie chart saying I've got 20% of the pie, right? It doesn't matter how large or small the circle is. I know I've got 65 of the 360 degrees. So to be extra clear, what I mean is, this is like saying you have a percent of the pie or portion of the pie. So the measure is some ratio, portion, percent of the circle. You don't know how big or small the circle is, right? I could have a 180-degree arc, but that could be of a circle that fits in the palm of my hand or a circle as big as the planet, right? A 180-degree arc would mean I have half of a circle, but I know nothing about the size of that circle. So just to go one step further on that, for two arcs to actually be congruent, they must have the same measure, okay, so 180 degrees, that's half a circle, great, and the same radius. If they're from two totally different size circles, then the arcs can't be the same. So to highlight that here, here's an example. This arc LP here has an arc measure of 85 degrees because the central angle opening up to this is 85 degrees. But the measure of MN is also 85 degrees because they're the same portion of the circle, right? It's 85 degrees out of 365. So they have the same arc measure. However, obviously they're not the same size. One of the circles is larger than the other. So these are not congruent arcs, but they do have the same arc measure. Okay, and we'll come back to this as we talk about arc length a little more. All right, so an arc measure is defined as the central angle. Okay, so let's actually name an arc now. So just like a line segment or a line or a ray, we've got a symbol. So we say the arc from A to B, we go capital A, capital B, telling us the starting point and the end point. So it's named by its two endpoints. And the symbol looks like a rainbow or an arc. And so just a rounded top arc. So just be clear that it's not a line segment. It shouldn't be looking kind of flat where it's ambiguous. Definitely a rainbow arc over this AB. Okay, so it is always implied that you're talking about the smaller arc. If I were to just draw a circle up here and say, okay, here's a circle and here's point A and point B, I am always talking about this pathway. I am not talking about the longer way, because right, always from point A to point B, you could go clockwise or counterclockwise. There's always two ways you could go to get to B. I mean, it's a circle. You go full circle, you end up at the same spot. But what if you want to talk about the bigger angle, right? That's totally okay. You can. You just have to avoid the ambiguity and say, well, obviously, if I say arc AB, I'm always talking about the smaller one. So if I want to talk about the other side, I just have to add something like the point C there and say, well, if I want to talk about this arc, same thing with an angle, there's no ambiguity. You say, now I'm talking about arc ACB. So I'm going from A to B, passing through the point C. Okay, that's different from arc AB, which is the shorter one, right? So this one is the shorter one. This one is the longer one. Those arrows are all crisscross. But this is the same thing with an angle, right? You could call this angle P, but you could not say angle P anymore because now there's 1, 2, or 3 angles there. So no ambiguity. You need 3 letters if you're talking about the other side. All right. I wrote that here. If you want to refer to the other longer one, you just say, oh, look, I've got ADB, saying starting at A, going through D, and then to B. Or you could talk about the smaller one, which is just AB. Okay? So the last vocab here is we just want to be able to refer to whether we're talking about the small arc or the big arc, except using a little more technical or more accurate terms. The words we're going to use are a minor arc is something that has a measure less than 180. So up here, AB is a minor arc. It's less than a diameter, 180, right? Major arc is the other side, right? 360 minus the smaller one, the leftover of the circle. And that one's bigger than 180 degrees. And then finally we have semicircle. So semicircle has a measure of exactly half of a circle, or 180 degrees. Okay, so let's actually go ahead and use this to do some problems now. So using those definitions, the first problems on the homework say, okay, well, first determine whether it's a minor, major, or semicircle, and then find the measure. So what I'm going to do is I'm going to go down to this picture first and find all these angles. So these are the same ones as we did before. So I'm going to say, oh, look, this whole thing's 180 here because of this diameter. So I'm going to say 180 minus 45 minus 70. That gives me 65 degrees. And of course, this is a diameter too. So this one must be 110 because it's 180 minus 70. And then this one over here is just vertical angle. So that's 70 because it's a vertical angle. So now that I've got all my angles, I'm going to go back over here and let's see. So number 3 says, find the measure of this arc. So the measure of arc BC is, so from B to C, the short way, not around the other part, the central angle is 70 degrees. So that has a measure of 70 degrees. And of course, since that's less than half a circle, we call that a minor arc. Okay, DB now goes through C, and again, I'm doing this smaller, less than a semicircle because it didn't use 3 points to say otherwise. So DB, well, the central angle there is 65 plus 70. So 65 plus 70, that gives me a measure of 135 degrees. And again, even though it's in the hundreds, it's less than 180. It's less than half a circle. So we're going to say that's the minor arc. The major one, if I took another color from D to B, would be something like this. Okay, and I could label that as DEB, DAB, but I'd have to use a point to say go from D to B using the other side that has the E and the A. All right, so let's do another one. We've got A to D. So A to D here, again, using the short one, that's 70 plus 45. So the measure of AD is 115. And we're talking about less than a half a circle, so this is still a minor arc, less than 180 degrees. Now ACD is using 3 letters here, so let's look. We're going from A to D, except we're not doing AD that we just did number 7. Now it's saying, I want you to start at A, go through C, and then go to D. So it's talking about this direction. So in that direction, well, that's going to be the exact opposite of the one we just did. So the measure of ACD is just, well, 360 minus its counterpart. We just found out that AD was 115. So what's the other direction from A to D? The other direction is 245. Right? And those two added together make a full circle. So I went from A one direction and then A the other direction to end both at D. So total, I covered the whole circle. And since that's bigger than 180, that's a major arc. Okay, so that's it for today. I hope you enjoyed that. Good luck.